come on in and have some fun.
Come on.
So just come in and learn with us with the mouse in the house.
Woohoo!
With Tatiana, Johan, Michaela,
Yeah.
and Kiri. So come on, young scientists, come join the mouse in the house.
Hi guys, my name is Max. Welcome to my lab. When you mix chemicals together, it may take some time for a reaction to happen. But not today. In this experiment, we're going to produce a timed chemical reaction with our iodine clock reaction. Same colors, same time, every time. You will need a number of chemicals to mix into 3 solutions. For solution A, you will need starch, some sodium sulfite, and sulfuric acid. For solution B, you will need mercury chloride. And for solution C, potassium iodide. And 3 glasses. Now let's get chemical. Pour solution A into the first glass. And solution B into the second glass. And solution C into the third glass. Now, pour the mixture of solution A into B. And then into C. And wait to see what happens. Wow! That's cool! Keep watching. Look! It turns into an inky black color. Amazing! Now you do it. Pour solution A into the first glass. And solution B into the second glass. And solution C into the third glass. Pour solution A into B. And then into C. Be careful not to spill. And wait to see what happens. Wow, that's cool! Keep watching. Look how the colors change. First we had lemonade, turned into orange soda. And now we have cola. That's amazing!
How does it work?
This is an example of a timed chemical reaction, where certain chemicals take a certain amount of time to react. This results in a specific color occurring after a specific time.
Will it always change to those colors?
Yes, unless you use other chemicals that can produce other colors.
Does the reaction always take that long?
Yes, the reaction time is fixed and it can be determined very accurately. All these changing colors make me wonder how hair dye works. Hair dye is a chemical that is used to change the color of a person's hair over a certain amount of time. A timed chemical reaction. As you can see, the young scientists in the studio are having fun with temporary hair dye, which can be used at Halloween parties or as a fun way to add a new twist to your look. So have fun and see what crazy and creative looks you can come up with. Now for my green tip of the day. Walk or ride your bike instead of driving whenever possible. This will decrease the amount of pollution in the air. That was a really colorful day. And that's what science experiments are all about. See you next time. Have you ever wondered how elephants keep their tusks clean? They use elephant toothpaste, of course. So join me as we make elephant toothpaste. You will need hydrogen peroxide, a glass tube, an empty plastic bottle, dishwashing liquid, and potassium iodide powder. Now let's begin the experiment. Pour the hydrogen peroxide into the glass tube. Take a few teaspoons of powder and put it into the plastic bottle. Add dishwashing liquid in the bottle. Now pour the hydrogen peroxide and watch as the giant toothpaste forms. Now we have the toothpaste, so the only thing missing is an elephant. Now you try it. Pour the hydrogen peroxide into the glass tube. Take a few teaspoons of powder and put it in the plastic bottle. Add the dishwashing liquid. Now pour the hydrogen peroxide and see the toothpaste ooze out. Kids, remember to be very, very careful when using chemicals.
How did that happen?
This is a catalytic reaction between the potassium iodide and the hydrogen peroxide.
Why does it get warm?
It gets warm because it's an exothermic reaction, which is a reaction that produces heat.
Does the foam harden after a while?
No, it will disintegrate. So now that we've made the toothpaste, let's jump into my space pod and go and find the elephants. Come on! The elephant is the largest animal that lives on land. Elephants weigh as much as 9,000 pounds or 4,200 kilograms. Wow, that's heavy. So kids, do you think it's as heavy as a car? No, it's actually as heavy as 3 minibuses. Gigantic! Come kids, let me show you more interesting facts about elephants. Did you know that elephants push trees down with their heads and tusks and pick the tastiest leaves with their trunks? That looks delicious. Did you also know that if an elephant breaks its tusk, it will not grow back? So remember to take care of your teeth by brushing them every day. Time to jet back home, kids. See you at my lab. Today's green tip is, get your parents to start using energy-saving bulbs. Today we had fun making elephant toothpaste and learned more about the majestic elephant. Stay hip and cool with science at school. Bye, kids! Stalactites and stalagmites are large crystals which grow in caves. Today, we're going to grow our very own baking soda crystals. You will need a bottle of water, a glass beaker, some baking soda and a teaspoon, a small stick and a piece of string. Now let's begin the experiment. Pour water into the beaker, about half full. Add 1 teaspoon of baking soda into the water and stir until most of it dissolves. Add 1 more teaspoon of baking soda into the water and stir. Make sure that you mix it in very well. Now, find a baking soda crystal that is big enough and tie the string around it. Make sure that you tie it tightly. Wrap the string around the stick, leaving a piece which can be carefully placed in the water. Make sure that it's properly immersed in the water. Crystals will start appearing on the string in a couple of days. Wow! Look how the stalagmites and stalactite crystals have begun to form on the string. Wow, that's incredible. Now you try. Remember that this one takes a little time, so don't worry if you don't see results straight away. Pour the water into the beaker. And using a teaspoon, put some baking soda into the water. Don't forget to stir so that most of the baking soda dissolves. Now tie the string to the crystal and put it into the baking soda solution. Don't forget to coil the string around the stick. Now, let's take a look at one that was done a few days ago on a paper clip. Wow! Look! It's growing into a big crystal. It looks like a diamond. Amazing!
How does it work?
The string provides the surface on which the crystal can grow. As time passes, the water evaporates, making the solution more saturated, and small crystals of baking soda will start to grow in the string.
How can I tell the difference between a stalagmite and a stalactite?
Stalactites are stuck tight on the ceiling, which makes them grow downwards. And stalagmites might reach the ceiling, which means they grow upwards. That's clever. Let's go into my space pod and go see beautiful tripping formations and caves. A cave is a natural underground space that is large enough for a human or a mouse to enter. Stalagmites and stalactites are large crystals which grow in caves. The world's largest stalagmite is 32.6 meters long. Okay, kids, let's get back to my lab. Now for my green tip of the day. Start a small vegetable garden in your yard. It's greener, cheaper, and it's just a walk away. Today, we've learned how to make our very own stalagmites and stalactites using baking soda and also saw real ones. Bye for now and happy experimenting. Today, we're going to make a spontaneous kettle. You will need hydrogen peroxide, a little metal kettle, a tea bag, manganese dioxide and a teaspoon, and a stapler. Let's begin the experiment. Open the tea bag and empty out the tea leaves into a dish. Replace the tea leaves with half a teaspoon of manganese dioxide. Close it up again and staple it shut. Add a little bit of hydrogen peroxide into the kettle. Add the tea bag and put the lid on quickly. Watch the reaction. It's a steaming kettle. But not to drink, just for fun. Come on, kids. Now it's your turn to make some tea. Carefully open the tea bag. Empty out the leaves. Add half a teaspoon of manganese dioxide. Staple the tea bag closed. Careful! Pour the hydrogen peroxide into the kettle. Not too much. Now drop the tea bag and very quickly put the lid back on. Wow! Look at that steam! Kids, you must be very careful not to touch the kettle because it's very hot.
How does it work?
The manganese dioxide is a catalyst for the hydrogen peroxide. It causes the hydrogen peroxide to break up into water and oxygen. This is an exothermic reaction, meaning that it produces heat. This makes the solution to boil, causing the steam.
Do I have to use a metal kettle?
It is preferred, but any non-electric kettle could be used.
Is this dangerous?
Yes, it is. You must be very careful of hydrogen peroxide because it can burn your skin. Don't get too close because it also has a bad smell too.
Does the kettle get hot?
Yes, it gets really hot. So be careful and always make sure that an adult is present. Now let's get into my space pod and go enjoy a tea ceremony in Japan. The Japanese tea ceremony, also called the Way of Tea, involves preparing powdered tea for guests according to the custom and enjoying it quietly and serenely. The tea ceremony is meant to clear the mind and for you to become one with nature. Okay, now let's get back to my lab. Today's green tip is plant a tree. A single tree will absorb 1 ton of carbon dioxide over its lifetime, and shade from the tree can also reduce your air conditioning usage. So today, we learned how to make a spontaneous kettle and saw a traditional Japanese tea ceremony. That's all for today, kids. See you next time. Do you believe in flying saucers? Well, today, we're going to see how static electricity works and how to make flying saucers. You will need aluminium pie tins, a doll, a sharp-pointed object, metal hoops with strings attached, and a Van de Graaf generator. Let's begin the experiment. To test the static of the various objects, first place the metal hoops and the strings on top of the generator. Switch on the generator and watch as the strings react to the static. Now, use the generator to create sparks. Look! They look like lightning! Cool! Now try with the doll. Wow! She really needs a serious new hairdo. Now for the flying saucers using the aluminium pie tins. That's way cool!
How does the generator work?
The rubber bands inside the generator picks up the electrons and deposits them onto the aluminium bowl.
What is static electricity?
Static electricity is the result of an imbalance between negative and positive charges in an object. These charges can build up on a surface of an object until they find a way to be released or discharged.
Can it shock me?
Yes, it can, and it will definitely hurt, so please be careful. Now you try creating static using a balloon. Here you can see quite clearly that by rubbing a balloon on your hair and touching your friend's hair, that it creates static. Now, rub the balloon against a furry cloth and try to pick up pieces of paper. Wow! Look at the static electricity in action! Go around the house and see what else will create a static electricity. Here's a tip. Rub your feet on the carpet and see how many people you can shock. Talking about shocking, let's look at this at a larger scale. We're going to learn more about lightning. Lightning is a big charge of electricity that can reach from the clouds to the ground or to other clouds. Lightning is exciting and frightening at the same time. Remember, during a lightning storm, seek shelter in a house or a large building. Stay away from trees because they can't be the highest point close to you and more likely to be struck by lightning. Whoa! That was close! Let's get back to my lab where it's safe. Let's go green with today's green tip. Don't kill spiders because they eat insects and provide natural pest control. So you don't have to buy pesticides that are bad for the environment. That was shocking indeed. Get it? Shocking indeed. Today, we learned about static electricity and lightning. That's all for today, kids.